Hello again, eighth graders. Thank you for being patient. I wasn't able to upload anything yesterday because I'm having some computer issues, but hopefully they'll be fixed. So my loss is your gain because you do not have a quiz today. What I want you to do today instead is watch this video. We are on textbook page 365. I'm still in topic 3, lesson 3. Okay, as per usual, let's start off with a quiz. So warm currents, remember last lesson we were talking about surface currents, from the equator flow towards A, the equator, B, poles, C, prime meridian, or D, northern hemisphere. 5, 4, 3, 2, 1. I'm going to get rid of some answers. I'm going to get rid of equator because the equator, from the equator to the equator doesn't make a lot of sense. I'm also going to get rid of prime meridian because I've never mentioned that before. And if I haven't mentioned it before, it's usually not the answer. So what do you think? The surface currents take warm water from the equator and spread it out to the poles. So that kind of like warms up the rest of the world. Okay, so speaking of surface currents, today's goal is going to be surface currents and climate. Have you heard the word climate before? Well, before we begin, it's going to be really important that we understand the difference between weather and climate because they're similar but not the same. Okay, so let's talk more about weather versus climate. All right, so weather is short-term change in the atmosphere. So it's something that happens over a short period of time, like hour to hour, day to day, week to week. But climate is the temperature and precipitation, that's just a fancy word for rain, of an area over a long period of time, like decades and hundreds of years, so much bigger time scale. So I like this little diagram. It just basically says the same thing. So weather is short-term variation or changes in the atmosphere, and climate is weather condition over a long period of time. So sometimes if people are talking about climate change, and the general pattern of climate change is the temperature increasing. And they're like, well, in Buffalo, this winter we had snow, so climate change can't be real. Or this spring in Buffalo, it's been really cold in April and May, so there's no way that the planet is getting hotter. Well, that's not correct because when I'm talking about what happened this winter or this spring, that is short term, so that is weather. So yes, it's cold, yes, it's been snowy, but the overall pattern of Earth, the climate has been getting warmer and warmer and warmer and warmer. So you got to understand the difference between weather and climate before you can really start talking about climate change. Okay, we're also going to review something that maybe you guys learned in geography class or history class, longitude and latitude. So let's start with longitude. These are imaginary lines that go north and south or up and down on the globe. So here's an example. So they're long, they're going up and down. Latitude is going to be opposite. It's imaginary lines that go across the globe, or I like to say side to side. Okay? So we need to know the difference between longitude and latitude. I think you guys already know this, so hopefully this is just review. But in case it's new, let me test you. So I've got globe A and I have globe B. Which globe shows longitude? Which globe shows latitude? So if you don't remember, just rewind me a little bit to get to the last slide that we talked about. Give you a few seconds. All right, so hopefully you said globe A shows latitude because they're going side to side. Latitude is imaginary lines going side to side on the globe. And that means that B must be longitude. I always think if someone's long, they're tall, and you measure someone's height like up and down, north to south. Okay, so another question. I want you to think about Canada, Russia, and England. And I want you to like picture, when I say those countries, like what images do you get in your mind? And specifically, what do you think about when you think about climate or average weather over a long period of time of Canada, Russia, and England? Have you ever thought about it? Well, I like to travel, so I did. So when I think of Russia, I think of, when I think about the climate of Russia, I think about snow. So that's the famous St. Petersburg Square. It kind of looks like Buffalo. And I just think of just really, 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 really cold temperatures. It's so cold that in that picture, picture is taken in Siberia in Russia, her eyelashes froze. And when I think about Canada, I think about hockey. They really like hockey. Why do they like hockey? Well, it's usually pretty cold there, so they can make outdoor ice rinks, and it's pretty snowy. They're our neighbors, and Buffalo's pretty snowy, so I think of snow and I think of cold. Now, when I think of England, I think of rainy, gray. I don't really think about sun or snow. I just think about rain, 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 rain. But if we look at a map, okay, here's a map. I zoomed in a little bit. We're going to see, let me circle on your map. Here is Russia in blue. Here is England in red. And then here is Canada sitting on top of the US. And if I look really closely, if I look at the latitude, if I look side to side, they're pretty much on the same latitude line. So why is the weather, or excuse me, why is the climate so different? Well, what did we learn last lesson, or what is the focus of this lesson so far? Surface currents. So surface currents are going to be responsible for the different climate. All right, so let me tell you how. For a warm surface current, it can redistribute or spread around heat from the equators, so the middle of the globe, to the poles. And that's going to bring with it warm and rainy weather. Remember, the temperature of the water is going to influence the temperature of the air above it. So that means that cold surface currents are going to bring cold water, which is going to cool the air above it. But when you cool the air above, it actually isn't really good at holding on to water. So cold currents are also going to bring dry air, and this is going to create a cool and dry climate. So just to put it in a nutshell, warm surface currents, warm rainy weather. Cold surface currents, cool and dry weather. Okay, so let's go back to our rainy England example. Remember, it doesn't really snow there, or it doesn't snow as much as, say, Canada or Russia, even though they're kind of on the same latitude line. Okay, so what's going to happen is we're going to have a surface current called the North Atlantic Drift that's going to bring warm water in northern Europe. So here's a map. I'm going to circle the North Atlantic Drift. That is our surface current. It's red because it's warm. And I'm also going to circle England again, okay? So that's why England is more rainy than Russia and Canada. And as you also look at this map, you're going to see when this current or surface current starts, it starts off as something called the Gulf Stream. And actually when it crosses the Atlantic, which is the ocean between North America and Europe, it becomes a North Atlantic Drift. So it's still warm. So that means that the Gulf Stream, I circled that in white, is going to bring warm water up the East Coast. Whew! Okay, that was a lot of information. Let's end with a little quiz. Cold currents create what type of climate? A, rainy and warm, B, cold and dry, C, rainy and cold, or D, cool and dry? 5, 4, 3, 2, 1. I'm going to eliminate some answers. I'm going to eliminate rainy and warm because remember, cold water is going to cool the air above it. And when the air is cold, it can't hold onto moisture. So it's not going to rain. So that means I'm also going to eliminate C because cold air doesn't bring rain. So what do you think the answer is? Letter D, cool and dry. Okay, guys, that's it. Thank you for being patient. I hope you have a good weekend, and I will hopefully see you back here next week.